All right, we are talking about crankshafts. Well, I'm up to G, which would be the sections of the crankshaft or parts of the crankshaft. Sections of the crank. This is going to be the easy part right here. So we got the main journals. Main journals, which are right there. So we got the mains. 1, 2, 3, 4. Because Lycoming says this is 1, that is 2, that is 3, and that is 4. And we've got the crank pins. Crank pins, also called Conrod journal. Also called Conrod journals. So those would be that, and that. And if it is a Lycoming, this is number 1. This would be 2. This is 3. That must mean that's 4. If it's Continental, it's backwards. Continental, because they're gold, that'd be 4. That'd be 3. That'd be 2. That'd be 1. Got your water.
Like with the bearings earlier when I looked this up there.
All right, let me see. B. So opposed engines, or boxer engines if you like. Let's see, have 1 throw per cylinder. Have 1 throw per cylinder. And a throw is just the journal. So the one we just looked at had 4 throws on it. They are numbered in order of cylinder placement, as I just showed you. Numbered in order of cylinder placement. So Lycoming has the 1 in the front, Continental's 1 in the back. Radial engines, they are different. Radial engines, they have how many throws? 1 throw per row of cylinders. So a single row radial will have how many throws?
1.
And a double row will have
2.
2. That's easy math. Let's see, we have the crank cheek. That is, right, change my color. Right there, that'd be the cheek. And I think the next thing I have on there is the fillet, which would be any of these little corners right there. So what do I got next? Yep, fillet. That's the radius at the end of each journal. So right there too. Crank cheek, and let me see. And 4, we have the fillet. And that is the radius at the end of each journal. All right, let's see, anything else I got to say about this? I guess so. I'm not going to write it, but up here on the crankshaft flange, we have the bushings. I don't know if I mentioned this here or some other place, but these bushings are not necessarily all the same. Some of them are different. They always take the same size bolt, but some of them are longer. Well, look at that. That appears to be about yay long, and this one appears to be longer because it is longer. And what that is, it's an index. And so there's a service instruction, shocking, that will tell you which engine where to put the indexed bushing, the longer bushing. And it could be a long one here and a long one over here, or just a long one there, or maybe a fat one here. This one, not to shame it, but this one may be fatter. So it could be fatter, longer, different types. And the whole idea is you as an engine mechanic are smarter than the average bear. And so you would follow the service instruction and you would put the index bushing in the correct place as per the service instruction. And then the person putting on the propeller, who is not as smart as you, would have an idiot-resistant way to put the propeller on, because the propeller will then be indexed to the different bushings. There'll be a different hole in the propeller. And so the mechanic should see that and then install it. Well, it doesn't work that way. So oftentimes what you get then is one bushing that is they're a little fatter. And so you need the fat hole to go from the propeller to go over that. But you get the mechanic who doesn't know that. So they put the fat one over here and the small one goes on here. Well, what happens when you try and put a small hole over a fat thing? Well, it doesn't sit on there very well. So being the incredibly brilliant mechanic that person would be, they just use the bolts, because there are plenty of them, we have 6 of them, to tighten up and pull the propeller onto the flange. Well, as they do that, they're usually using like this bushing and this bushing over here, because this one doesn't seem to work for some reason. They just tighten all of these other ones, and well, would you know it? That prop actually pushes all the way on just nice and neat. Except what happened to this bushing? It pushed it all the way out. Not all the way, it just pushes it out. So you have this big gap right here behind this shoulder because they all press in this way. Look, it's backwards for you. So they press in. So they just press that one out with the propeller. The propeller comes in. So you look at it and like, okay, one, the propeller is misindexed. Instead of being, this way at top dead center, it is now this way at top dead center, and you push the bushing out, and it'll fly that way for a very long time until some mechanic goes, well, how come when I do the compression check, the propeller should be like this, but it's not like that way. That way, but it's not. So anyway, that creates a problem. So those bushings are actually a thing. Don't screw with them. And let's see, there's a lot of information about that down there, which I think I'm going to get to in a little bit later. Hopefully. If not, I'll come back to it. Sounds good. All right. Okay, let's talk about counterweights. Bigger engines, where we're getting into the Lycoming 200 horsepower and up, they're 4 cylinders. I don't think anything below 200 has it. I could be wrong. We'll just say they're 360s, the Lycoming 360s, and the Continental probably 360s as well and up. Those are 6 cylinders. They have counterweights. Well, so does the radial engine I showed you, not to be confused with things. So let's see, which way do I got to go? Let's see. There we go. Obviously, this has gigantic, very heavy counterweights down here, but those are usually fixed. Not always. The smaller ones are, but those could be floating as well, but these counterweights have to be there, and they are fixed. This is just a crankshaft. It used to be. Somebody cut it very nicely right there. A lot of crankshafts have dynamic counterweights, not fixed. These would be called dynamic counterweights, and they're loose, and they're supposed to be loose. And if you looked in your book and you're reading about it, and I'll tell you, and you say, oh, of course, I remember reading that. Mm-hmm. The idea is if you were to take, and I should have made something like this, say a large nut on a string, and I hit that nut, it kind of comes back, and as it swings, I can hit it again, and every time I hit it, it swings further and further and further, right? So that's a dynamic, I'm setting up a dynamic imbalance. I want to say this. The power pulses from the cylinders actually resonate through the crankshaft, and that's what it's like. And so you get this out of balance. It starts to repeat itself. We do it by order. I'll explain that. So what they do is, well, if you took that same nut on a string and tied a string to it, put another nut down here, every time I hit that one, it would go this way, and this nut kind of counteracts it, right? So that's what these are. This is the counteracting nut. And, oh man, I'm trying to think. Some of the Continentals have 3 rows of these things, if I'm not mistaken. And then most of them have 2. So we'll say at least 2. On 6-cylinder, 4 cylinders usually have just 2 or 1 set. So you have a set here, and then you go a bit later and have another set. So there's these hanger blade bushing, or hanger blades, which are bushed, and they have the counterweights that ride in them, and they're loose. They're supposed to be loose. So like a typical 6-cylinder Continental, they'll have, and it's in a service instruction for Continental, it'll tell you, you're supposed to know this, which is weird. They'll have like 2 4th orders, a 5th, and a 6th order. And an order simply means, like a first order is something that happens every revolution of the prop. A 6th order is every 6th revolution, apparently. Not that makes any difference to me, but what it really makes a difference is an engineer thought of it. And these things are, when they work great. When you screw them up in grand fashion. And bad things happen. There have been a lot of problems with counterweights, I'll just tell you that. And if you look at it, they're not held in by much. You got a little snap ring, a plate, there's a roller in there, and bushings. So you got a bushing in the hanger blade that's replaceable. You got bushings, 4 bushings in each counterweight that are replaceable, plus the plates, plus the rollers. And you'd think it's relatively easy to put it together. I mean, you just put the bushing, put the roller in there, put the plates in, put the snap rings on them. But as you can imagine, these things are spinning around on that crankshaft for their whole life, and they're spinning a lot. If that snap ring happens to come out, and the plate comes out, then the roller will come out, and this side gets loose, and it just kind of swings out and slaps the crap out of the crankcase and destroys it. And you crash and have a bad day. We had a problem with the heat treatment on these, where the plates were actually working their way out through. And so there was this test we had to do. We had to get the special chemical and drip it in there and see if these were nitrited. These were nitrited. On and on and on. So what can I tell you? This is where I learned how to put in snap rings. Snap rings have a rounded edge and a not rounded edge. How would I want to do this? So if you look at a cross-sectional area, snap ring kind of looks like that. With a very square edge, kind of a rounded edge. It's just how they stamp them and how they make it. And so you always want it so that the force is going that way on it. So in other words, when I put the snap ring into this, that very sharp edge goes outside and the rounded edge goes on the inside. So if you're trying to push that way, it catches on that sharp edge. So I always install my snap rings, since I did those and I kind of learned that. It's the only place it says it. You must put them in that way so that the force is going, trying to push it out that way. One of the manufacturers, and now it's just kind of eluding which one it is, the snap ring. Got the little hole right there. Of course, there's some depth to it. You have to measure this distance. Oops, actually this distance right here. That distance, you have to measure it, and it's part of the installation instructions.
You measure from center of the hole to the center?
I want to know, because they give you can buy a no-go gauge where it's actually the space in between on the engines. So, but I can imagine do you guys have some stuff on your helicopters where it's hole-to-hole?
Probably.
Okay, well, these are not hole-to-hole, they're inside. Oh, it's Continental. And so you have to make sure that you have the proper distance. If you don't have enough distance, what does that mean?
Too small.
It's not engaged into the grooves. You haven't engaged it. And so, for example, so this is kind of interesting. So, right, I told you over COVID we were shut down here. And so I still got paid, and part of the thing that I had to do was I had to do X number of hours of extra stuff for the school and all kinds of stuff. Or I could go out and work in the field as development for doing this. And so just so happened that Nathan, who was here the other day, I don't know if you guys met Nathan, he called me up, said, hey, come, we have a problem. Are you available? I said, yeah, I'm available. And it was kind of interesting. He had an Air 182 had pulled up to the hangar. Did I tell you guys this story? No. I mean, if I did, you won't. You'll just take a nap. So the airplane pulled up to the hangar, and Nathan built engines with me. He was a really good mechanic. He could hear it making a weird ticking sound, which I'm very surprised he could hear it, but he couldn't hear it or something. And he was very concerned about it. And this airplane was also, it came in because it threw the alternator belt off the rear of the engine. So we had this problem, came in for an alternator belt, they could hear it making some sort of weird ticking, so they shut down the aircraft. He would pull the propeller through, and as you would pull it, sure enough, you could hear this inside the motor. And then it even got to a point where it kind of was weird, it kind of wanted to stick a little bit, but he called me and goes, just move the prop and tell me what you think, and it never stuck for me. He had to kind of show me how to do it, but you could hear this tick thing. And so what they did is they pulled off a cylinder, and they could look inside, and there's the counterweights. I mean, they just barely missed the case. So you got the hole right here you're trying to work through, and you can see it right there. Of course, you can't get to the back of it, you only get to one side of it. And they felt that it was one of the counterweights making that noise. So they had one counterweight off, and at that point they just kind of got stuck. Well, like we were talking about changing the bushings in here. I'm like, no, you can't change the bushings on the blade because you really got to do NDT on when you do that. You put a lot of stress on it. You're working on one side of the hole. Please don't change bushings. Anyway, long story short. Nope, too late. Long story long. So that's where I entered the picture. Hey, can you come in and work on this engine for us? Okay, so I come in. And so in experimenting with it and listening to it and working it, what I found is the crankshaft was going around, getting to a spot, and then you'd hear that. And what I determined after I thought, man, they already had one counterweight off. The other counterweight is making that noise. They diagnosed it. I mean, they were so close, they just pulled the wrong counterweight. Down here, it's called the bump stop, this part of the counterweight. And it will hit the crankshaft. You are not supposed to have dents in that. It's called a bump stop, but when you overhaul the engine, you got to look for any damage, any damage at all, dents, dings in that spot. Well, it had been dented and was actually catching on the dent, and so when it came around slowly, it would hold it in the dent until it got to this point, and then it would drop out of the dent. So we're hearing that resonate through the whole crankshaft. So I had to pull the other hanger blade, which they were never designed to be worked on in the engine. I'm like, oh man, you can make me do that. So I had to pull the snap ring, and then out in the field, we pulled both snap rings, and then if you kind of lay it down and tap here, because the plates are, snap rings and plates are non-reusable. So you can tap on this right here with a steel punch, and if you tap on it, it'll loosen this up. And then once that's loose, you use a strong magnet, pull out the plate, and you pull out the pin, and you pull it off. Well, imagine doing that when you can do one side of the whole damn thing. So I kind of had to figure out, thankfully the new styles have 3 little holes right there, so I had to figure out this way to get it out. Like, how did you do this? And so anyway, I got it out. And
through the cylinder.
yeah, all through the cylinder. Then, well, that was the easy part. Then I had to put them together. So I had to assemble one half of the plates and the snap rings, and then get it in there, and then work the pin in. Okay. Then I had to put the plate in. Now, once the plate's in, you actually have to take like a steel punch and punch it in around there because it's a press fit. So you can't get a hammer and a punch in there. So I worked out something where I could make a wedge and kind of pushed it. And the whole time I kept thinking, dear God, please don't drop any of these parts. Don't drop any of these parts. Don't. Oh shit, I just dropped it. So I dropped a plate straight down into the oil sump. Well, that's okay, because to get the oil sump off, all you have to do is pull the engine. So I spent like 2 hours trying to find that stupid plate. And it was, finally I had to go get some clean Stoddard solvent. I had to drain all the oil. I had magnets. I had my bore scope. I couldn't find Nathan's in there. I'm like, Nathan, it's right there. I know it. He couldn't do it. Finally, I just said, all right, I got to get Stoddard solvent. So I sloshed Stoddard solvent down in the oil sump, kind of move the plane around and kind of wash it, and then we'd hit the quick drain and let it go. Hopefully it would wash, and we did that enough times that finally it washed right up next to the oil drain tube, and that's the only way we could find it. So I got it out, put it back together. So anyway, that was rather interesting. But going back to the whole thing, you know, so I get it all put back together, and I take it out and I run it, and it's like, holy crap, this engine is freaking rough. I mean, it is just shaking. It's not pleasant to operate at all. So I called the owner and I said, hey, you know, I've got your airplane all back together. You can come take a look at it. And, you know, he got in and ran it, and he goes, wow,
That's smooth.
this thing is way better than it used to be. I'm like, you got to be kidding me, man. I've got this same plane. I would never fly in there. You got a problem. So anyway, you know, to make a long story even longer, he put it all back together, put the belt on, took it flying, and belt just flew off within 30 minutes. Brought it back, changed all the bushings in the alternator, put it back together. I know I told you this story before. Took it out.
You told us that part.
Okay,
You told us-
threw it again.
Fire, yeah.
Threw it again. I kept saying, man, there is something wrong with your engine. You know, you've got a problem. You've got to get this thing balanced. And so finally, they called out somebody who did prop balancing, and the guy came out and tried it. And he says, you are beyond the maximum weight that I can install on this. And so he had to end up, so he took the prop off, sent it out to get overhauled. The overhaul shop said, nah, the prop's too old, we won't do it. So he had to buy a new prop, and that was a whole nother disaster. But quit throwing the belt. So counterweights, you know what they are? They are a problem.
When you see them, run.
Mechanics do more damage to this stuff not knowing what they're doing than anybody else. They're really not that hard if you just pay attention, read the book. You've got to have the right service bulletin that tells you which position it goes in, what order it is, and what parts go in that order. Because most of the time, all the bushings are the same. It's just different roller pins that change the order. So, you know, inevitably, well-meaning mechanics, they're going to take it apart. It's like, wow, I got 4 of these things. I better make sure I get it back in the right spot. So what do? You got a big old number set and go whack! Put a big old dent in it right there. Well, you know, they got a big old dot. Well, usually just use a punch, put a dot here. They're smart. I'll put 1 dot here and put 1 dot right there on the crankshaft. Then I'll put 2 dots here, 2 dots on the crankshaft. Okay, don't do that. You're not authorized to be smashing dents into precision parts. But you can see there's a difference. That one's got a pin in it. That one doesn't. Put it on. Yeah, you just don't mark stuff.
Service bulletin.
Huh?
Read the book. Read the service bulletin.
Don't do it if you don't know what you're doing, because they're tricky. And if you get it off, you are going to you're going to have a harmonic balance. Okay, here's my harmonic balance story. So it leads into a good story. And Larry confirmed here the same story when he went to Lycoming. So it's the Lycoming story. So there's a story about somebody with, I think it was a 206, which would be a large 6-cylinder Continental, which had the counterweights. They were landing somewhere there in Pennsylvania. And as I've learned, when you're not flying here, there are deer on the runway. So here they come in for a landing, whack, nail the frickin' deer. All right, land the plane, get out. Yeah, it's a frickin' mess. It's destroyed the prop, you know. So by technical definition, and this is something I've seen in my career, they actually defined it, a prop strike to an engine requiring a complete disassembly is anything that requires the propeller to be removed for repair. So you got these bent blades, they got to go to prop shops. So that is a prop strike. The whole engine needs to be disassembled, cleaned, inspected, repaired as necessary. Often called an IRAN, inspect, repair as necessary, IRAN. And what is very normal for IRAN inspections on prop strikes is you take the prop off, you send it to the prop shop. Sometimes you just let the engine sit there because it always happens not at your own field. When the prop is done, you put it on and you do a ferry permit to where your overhaul shop is. Or you borrow a prop. So anyway, they take off the prop, put on another prop, and they ferry it, and it was a very short distance. I want to say it was a 30-minute flight at most. And as the story goes, they flew it, flew fine, no noticeable vibration whatsoever, out of the ordinary, landed it, and as they landed, the mechanics are looking at it going, that engine's not sitting right in the airplane anymore. And Continentals, they, unlike yours, they have these feet that are about that long that come out of the front of the engine and the back of the engine, and it goes to big rubber, and that goes to steel rails that are mounted to the engine, so it's got these little legs. Well, what they found out is that every one of those legs, it said, looked like a laser had cut through every one of them. It was the vibration had set up because it had detuned the counterweights to the point where it sheared the mounts, and the engine was about to depart company. But the people in the airplane never felt it because that vibration level was at a level that you can't feel. And I was at a seminar one time where they, and I didn't save it because it really goes way out there, but it talked about which vibrations we can feel where, as humans, where it annoys us, where it's uncomfortable, where we can't tolerate it, and this is just out of that range. It's like some, it's out of that range. So, I guess I tell you that story to say that detuning counterweights can be deadly, and the way you detune them is being harsh with the throttle. They say rapid starts, stops. To a point, I kind of don't believe that so much, but definitely any sort of abrupt stop will damage those because you have a roller inside of a bushing. And I think somewhere in here, because I'm getting ahead of myself, I actually wrote down, I did right here, a sudden deceleration. You have to think about two circles have almost this imperceivable amount of where they touch. They don't have much surface area at all. So let's see, a sudden deceleration puts about 90 tons of force on the bushings.
90 tons?
So it dents them. And then you get a dent. And I used to do this all the time when I take my engines apart before I do them.
That's a lot of
You
weight.
kind of run it in a radius like that. And often I could actually feel it. It would clunk into a little. Might feel a little bit on that one. You'd actually stop in that little spot, and that's what happens. So you get an indent in there. Instead of riding like a pendulum, it actually finds this little indent and it just becomes static. And so you lose all that. All right, so dynamic counterweights. A lot to them, huh?
Wow.
Counterweights, a dynamic damper. That's what I call my kids. It is a swinging pendulum. There are a lot of parts. I want to write all the parts. Well, I guess I started parts. There are parts. I could just do that. You have the CW is going to be counterweight. Counterweight hanger, or sometimes called the blade. This is the part that's part of the crankshaft. It's that part there. It doesn't come off. It's made into the crankshaft. So we got the counterweight blade. I'm going to move.
What was the counterweight what?
Blade. We have the actual counterweight. And they are position specific. Sometimes they're not. Sometimes they're all the same part number counterweight, and they just have different bushings or different pins in them. Sometimes they're different weights, and so they're all different. So you have the counterweight pins or the rollers. Usually those are the things that are different that gives it its order. B, C, D. What is D going to be? You have the counterweight plates. Those are these little plates right here that go under the snap ring. They're actually a press fit. You have to make sure, you have to measure the plate versus the counterweight. You have to make sure that it's an interference fit, meaning the plate is bigger. And the plates, actually, when you look at them, if I could draw a perfect circle, I would say they're not perfect circle. They usually have a little, just one or two little bumps on them. They're very small. You have to really look for them, but that's what holds them in place. And the counterweight snap rings, which I told you definitely go in a certain way. You have to measure the minimum distance. I could add one more, and that's counterweight bushings. I really, really hated changing counterweight bushings on the blades, because if you install it incorrectly and you pull metal while you're going in, because it's a press fit, so you have to have these tools, and you put the bushing on and you would tighten it with the wrench, you tighten it, it would bring it in. If you pulled metal coming in, you'd ruin the crankshaft. So it's just pushing a bushing in, you could destroy a $12,000 crankshaft. So it always scared me. Continental, you could change bushings in the counterweights, but light combing, you've got to actually grind them after they're in. So we always had to send out our light combings. Thankfully, I didn't want to do them. So what are these about? They are used to take out torsional vibration and power impulses. And then I give you the example like a pendulum hanging from a pendulum. Which is to say, if you have a pendulum and you get it swinging, it swings. But if you add another one to that and you put pressure onto that, I think your book uses the example of blowing on it. So every time it would come back, you give it a puff of air. It won't go very far, because when it starts to go this way, the bottom one counteracts it. And so by changing the length of the string, you could change the order of what it does. Cars don't have that, do they?
Not that I'm aware of.
I think it'd be too hard because they're just so finicky. I mean, I've had people say, never, well, in a car, we can jazz a throttle. Never, ever do that in an airplane. It's very easy. Even when you taking the center line to take off, you don't jam the throttle. It's very nice and even going in. Every power change is very gentle and gradual. IV, see order number. Refers to the rotation. Do I want to say that? Refers to, yeah, we'll say that refers to rotation. You understand order number, what I mean by that? Because Continental really uses that a lot.
The bushings?
The counterweights, the whole counterweights.
Oh,
They'll
shit.
say this particular crankshaft has 2 4th order, a 5th, and a 6th order, which I think is most of them, counterweights. And you're like, what does that mean? And I'm telling you what it means, because that's as far as they tell you. It's just got 2 4th orders, a 5th, and a 6th. Put the 2 4th orders here and the 5th and the 6th like that. So it refers to the rotation. So first, for example, first order is every rotation. And a second order is every other rotation. It almost doesn't matter if you understand that. You just understand, they're going to make up a name for it. You got to put it in the right spot. Counterweights. Can be detuned, which is serious. And then I had the story about the guy hit the deer. They even did a run out on the flange. So used to be, wasn't that long ago. I mean, getting to be, it's like 20 years now. But when I was, in the field, and for several years, if you had a prop strike, and a prop strike, AC 4313 would talk about how you would take off the propeller and you'd do a run out, just like you guys did a run out on the crankshaft flange going this way, right? See if it wobbled. So you were allowed to do that. And if you 4313 would have some dimensions in there, and as long as you didn't have too much run out, you were fine. If you had X number, I'd say they said you had to take the engine apart. Well, then Continental Lycoming finally came out and said, hey, no. If the prop has to be removed for any reason, because of a sudden stoppage is what they called it, didn't even have to have a prop strike per se, but if it stopped in like 1.5 revolutions, or the prop had to be taken off, because thick grass, if you hit thick grass, and it slowed the prop down or stopped the engine because of thick grass, that counted. That's when they came out and said you have to do a complete disassemble, repair, and inspection, which is what I did a lot of. You'd be just shocked how many prop strikes are out there. So anyway, yeah, you used to be able to do that.
Top security.
Anybody see that movie? It's an old movie, but it was the Rocky and Bullwinkle movie. There's a scene in there where they're using a biplane.
I haven't seen it.
All right, it's an old movie. Not that old, but I remember when they were shooting that movie, they shot it right out here off Clarksburg, and they were using a Stearman, and they called us up. They had left the brakes off and left it running, and it ran into the back of a car or something. So I didn't go out there, but one of the guys I worked with went out there, and he just did just do a dial indicator on the crankshaft. I'm like, damn, man. Okay, you're cool. So detune happens when there's a flat spot created in the bushing. So,
That's spot in the
yep. Detune happens when a flat spot is created in the bushing. Roller or both. So detune can happen. This is my Continental, I'm sorry, Lycoming guy. Detune can happen by the way, for what it's worth to you, and it should be worth a lot, this 4-week class teaches you more than everything you will learn at the Lycoming school if you went to the initial and advance. There's a 1-week class, you have to, it's a prerequisite, then you go to the advanced class. Everything I'm teaching you comes my experience, plus I took all of the notes and everything they taught, I came right back, imported it into everything I'm teaching you. So if you went there and paid the money, everything they say, you'd be like, oh, Kevin already said that.
So familiar.
Yeah, I already said that. No. If they lied, then I'm lying to you too. So, all right, quick throttle changes. Okay, I don't believe all of this. I will tell you that. This is, gets what I'm saying. This is what I got from Lycoming. L-E-T-T. Letting the prop run the engine. Maybe I'm being an idiot. I don't buy it. Which is to say that you pull the idle all the way back. So if I pull the idle all the way back on my plane, or anybody does in their plane, it should idle about 650 RPM. So if I pull the idle all the way back in my airplane, which should be 650 RPM, but I'm coming downhill because I'm descending, and I look over, my RPM is anything more than 650, I'm letting the prop run the engine. I don't know about you two gentlemen, but I do that every time I fly. And so then there was some statement made by, way back in the day, some of the radial engines had this problem. And then they said, oh, yeah. And they had like some model number. So I don't, if that happened, I've detuned mine to the point where I need to rebuild it every time I used it. This is possible. Feather at high RPM. Feather at high RPM. Okay, what that means is we're talking about constant speed propellers on twin engine aircraft. So constant speed propeller means that the blades can actually change their angle. Well, on a twin engine aircraft, you got an engine out there and an engine over here. If this engine over here, or that one of them quits, and that blade is still in normal configuration, the engine quits, but now you're flying, and then the wind has to drive that blade to drive that engine. Well, let's just say that engine over there has had some catastrophic failure and it's really dragging. Well, now that you've got a prop that's trying to drive an engine that won't turn, or a bunch of other problems, you get a lot of drag out there. When you get drag out there, now the airplane is you're going to yaw real bad, and you're going to have a hard time going that way, and so that creates death. So on a twin-engine aircraft, propeller will twist so that both blades are just like the wing. They go right into the wind, and so the engine will come to a stop. So that's feathering when they're into the wind, so the engine will stop turning. So if you were running at a very high RPM, you're cruising along, you're near red line, and you say, I'm going to feather it, and you just reach over and you grab the prop control and pull it all the way back. That's really bad. It comes to a very sudden stop. Number one, because the wind is no longer helping. Number two, our engines just aren't designed to take a blade that's flat and spin it. It doesn't work real well. If you hang out around an airport and you can hear people who have constant speed propellers, you guys have fixed pitch? Okay, so constant speed propeller, that's one of the procedures before you take off is to verify that your governor and propeller are working appropriately. So your engine is warm, you do a magneto check, and then you take your prop and you pull it back and you go to low RPM, high pitch, and the blades will turn. What I do is I watch my instrumentation and listen. The minute I can see a change or hear a pitch change, bam, I just quit, I'm in. But my hangar faces the run-up area, so and I've been hurt it my whole life. People pull that knob back, and it sounds like, I don't know, what does it sound like? It's just, you hear the RPM just, whoosh, it just drops down to almost nothing, and you can hear it struggling, and then it goes up, and the manifold pressure just peaks out. It's like, oh God, that's horrible. And they'll do that 4 times. Not just once, and they'll do it again and do it again. I'm like, I was never designed to do that, so don't do that when you run up airplanes. Or obviously a prop strike. That's right. I said sudden deceleration. Puts, let's say, up to or about 90 tons of force. 90 tons of force on the bushings. You think, no, there's no way it's 90 tons. I don't even remember. I will get into it in the next class. It's in my notes. How many tons of force are actually on a propeller in normal operation? I want to say it's 20 tons. It is just an incredible amount. That's why I never stand in line with a propeller. If they're running this way, I don't stand here ever. I'm like, the prop's going to come out at me. Let's see. Dynamic. Oops, that's not what I was trying to change what I wrote. We'll say counterweights. Are always used in radials. Because it's only got one throw. So it's out here by itself. You got to have something on the other end. So always using radials. It may use fixed weights or dynamic. I think the 2800 that we have, which by the way, I brought out a power cord. You guys plug it in anytime you want to watch it. That has dynamic counterweights on it. All right. Let's talk about prop shafts. Got to know the different kind of prop shafts. Well, right there, that's a spline shaft. Has splines on it. Get around to that. There we go. Another picture. Spline shaft, tapered shafts, and flanged shafts, which you should be intimately familiar with. And none of those are flange shafts. Well, you know what a flange shaft looks like because it is on your particular engine. That's a flange shaft. So 3 types, right? dinner bell. Angel gets its wings. All right, prop shafts. One, we have the tapered shaft. Tapered shaft has a large keyway. Or a shear key. Stop at that one right there. Let's go over to my picture. So that's tapered shaft right there. Here's another just right here. Because it's tapered. And it's got a cutaway right there, which represents, it's got a large square key that fits in there. Well, propellers aren't tapered. Crankshafts are tapered, propellers are not. So if you have a tapered prop shaft, you have to have an adapter. There is said adapter. Don't put your finger in there. But you can look in there and you can see that there's the keyway where it goes. Keyway holds it in, and I suppose under a prop strike condition, and I've seen it, you could shear the keyway, but you gotta take the engine apart anyway if you've done that much damage. So this goes over the shaft, and this nut then goes on there and tightens up, and there's a hole here that corresponds to the holes there. You can see at the end, and you put a pin. Pin goes inside out. That way centrifugal force holds it in. You put a cotter pin, and that is safety. Well, here's what you got to know about these. This will make you the genius of the day. When you want to take a taper off, you can see it's got a loose nut on there, and there's a pin, or what do you want to call it, a C-clip in there, circlip in there. So, the super mechanic looks at that and goes, well, this nut tightens down and locks it, but it's got that lock in there, so you got to get the lock out, and you got this off. So, it's very, very difficult, but if you get enough screwdrivers and you work hard enough, it's really, really difficult to get that key out there. But if you finally get it out, you can take this nut off. So now you're sitting there, you got the nut on the table, and you got that clip on the table, and you got this smashed onto the taper. And if you know anything about tapers, metal on metal, when it's on there, it's freaking on there. So how are you going to get it off? Well, Yep, you got a torch, you got a puller on the front, kind of pull this, which ends up bending this. And I had, I think it was when I was in this program, the teacher talking about a story about how, they went to lunch one day, flew somewhere and walked by this engine, and, that's the case. Everything's laying there, but this is stuck on the crankshaft, right? And this is his story, probably full of crap. And so, they go have their lunch and come back, and, now there's, the mechanic's missing, but now there's a torch sitting there, a puller sitting there, and stuff hanging off of this, and it's still stuck on there. And I think they went and did something else and came back later, and the mechanic was still gone, and and it was looking even worse, and now there's burn marks all over it. It's still on there, so they thought, let's just take it off. And so, according to his story, this is a tool. It has two functions. Function one, it holds it onto the crankshaft. Function two, it's a puller. That's what the clip is in there for. So when you loosen it, it suddenly gets loose, then it gets really tight. Well, when it gets tight, it's because this is now pulling on that clip. And you twist it, and it pulls it off the crankshaft. It's a tool. It's 2 in 1. So they, according to the story, they put the clip back in, they put this back in, put the tool in here, unwound it, knocked it off, took everything else off, put it back where you had it, got laying there at the airport, walked away.
What
I don't know what happened.
happened?
So on the airplanes I worked on that had these, every annual I told the owner, hey, if we're smart, we take it off every year, put a little bit of anti-seize in there, clean up any corrosion, put it back on. By the way, you are supposed to put this stuff called Prussian blue. Prussian blue is this inky substance, and you can smear it on here or on the shaft, not both, one or the other. You put it on, and you should have, and then you put just a little smearing of it. You install it, and you pull it off. So if I put it in here, install it, pull it off, I look at that, and the ink should have transferred to 70% of that. If it doesn't hit 70%, which is a C, so I remember it. Then you've got to either replace this or machine something or another like that. But all right, so that's the story for that. It's also missing. There's one more plate that goes up here, and the prop kind of fits in between the two. But all right, so I guess that means it's break time.
Break.
Good stories, huh? You're like whatever.
Keep them coming.